speaker is Martin Schobben from Vienna, University of Technology. And he's going to be talking about our iRODS and our client for iRODS.
Yeah, thanks a lot. Yeah, I'm going to talk a little bit about the journey, like of a complete revisioning of the R client for iRODS, also known as rirods. And just to point out a little bit, so I'm not part of like a bigger production team or managing something like that, but I did get some valuable contributions from outside. So I really want to thank iRODS, especially also Terrell, for all the help. And also from Utrecht University, I got some help from Christine Steiger in terms of especially infrastructure support. And then also I want to mention Mariana Montes, who also contributed quite a bit already to this package. So it is a team effort. So first of all, I want to guide you a little bit through the R landscape or ecosystem, as you will, to get a bit of an understanding of why we need iRODS there, and maybe also the other way around. What could R bring to iRODS? So when we think about R, it's a higher level programming language. So it stands quite close to the data analyst, would it be in the lab or in the office. It's open sourced. It has a very active user community. So there are people using packages and the software available, but there are also people actively producing new software packages and extensions. And the emphasis of the platform is really based on statistics and visualization of data. So data science in general. And you can see here in this plot that it is highly popular. Maybe it's a bit of an outdated poll survey here, but as a data science platform, it's trailing a little bit behind Python. And so it's really out there. It's an important platform to target. And also what you can see here is already the output of one of my favorite packages for visualizing data. So you can already see a little bit of the power of R. What is also great in R is that you can create reproducible workflows. There are some really cool tools for that. And then together with your Git repository and also your remote Git repository, you can make then your workflow reproducible. And so looking at this phrase in the middle here, so when you make your analysis and you're looking back to your past notes, you can always figure out what you did there in what step in your analysis, for instance, in your regression model. But when it comes to the data itself, reproducibility is maybe a little bit more constrained. So we do have some useful tools there, a package called DBI that enables you to interact with like SQLite and PostgreSQL. So you have access to centralized relational databases, but this is then intrinsically still a tabular database. So it requires sometimes that you have to reformat your data. So the question already arises then, can we store our objects just as they are? And so that maybe already answers a little bit the question here. So what if we use an iRODS in combination with R? Now, well, we have then that freedom. So we are loosened with the strict formatting requirements. And so when we think about that, that means that we have less data transformations to be able to get into this tabular format, and we get a higher productivity in our workflow. I try to exemplify this a little bit in this example here, which is the BMI, so the body mass index example. You see it in many textbooks. So we have the height and the weight, and we do a simple linear regression model here. And we store that as an object BMI. And we create here a summary object out of that. And in the next slide, you will see then what the output would be printed from your R console. And you can see that there was a lot of information in this object. So you have your residuals, your coefficients, coinciding with also your t-values, your Fisher statistics. So you can see already from the summary that you have a very complex object, which is not easy to store in a tabular format. So it would be handy if we can just store it as is. I think the other great benefit of connecting with iRODS would be that you can also describe your data. So you can annotate it with metadata and thereby make it findable and also shareable. So that is not only handy for your future self, if you want to go back to what you did in the past, but you can also share more easy parts of your analysis with your colleagues. So if you go back to the last example, so the body mass index, so what was this object again? Well, now let's have a look at what the new rirods package would do in terms of output. So this is the ILS command, which is familiar for people from iCommands, but then an envisioning in R. So if you print that, we can see that we get not only the object and the path towards that object, but we can also get the metadata, the AVUs associated with that. So we can already see again that we are dealing with an R object and that the content of this object was a linear regression. So now let's roll back a little bit and talk a little bit about how we got on this path towards an R package that we hopefully can publish quite soon. For that, we have to delve a little bit into how you want to make a package available to the bigger community. So ideally, you want to publish it on the Comprehensive R Archive Network, or CRAN. But CRAN, and for good reasons, has a philosophy that can be quite strict. So you need to have a very portable package. So it has to run on multiple operating systems and distros. And it also has to be stable. So they want to ensure that we have a stable ecosystem of R packages. So what now constitutes then a good package? Well, it's maybe quite easy to envision. So of course it needs to be tested, but tested means then also tested on the different operating systems. So it has to work on Linux, but also on Windows and also on Mac OS. It needs to be well documented, and that is then in terms of all the arguments that go into a function, but also examples that show you how to use the function. So it can be quite comprehensive. And this is all formalized in the RCMD check, which is a lump sum of 50 plus tests that you have to go through before it can be deemed eligible for publication. Now, a short history of R and iRODS together. So some of you might know that there was already an R package in the past that used the iRODS C++ API. It's nowadays archived, this Git repository. And so the new package builds around the iRODS REST API. And I think this table that I made here is maybe a simplification, but in terms of portability, that is of course means a big deal, because now it will be easier to use it also on Windows and Mac OS. And also in terms of stability, it's probably better because you only have a minimum amount of logic that wraps around these endpoints of the REST API, where the bindings with the other API were quite comprehensive and complex in some cases. So now let me take you a little bit through the global design. So as you already seen a bit, is that we try to mimic the iCommands where we could, but we also introduced some specific R functions that I want to show in a short demonstration in a couple of minutes. And we also try to only expose here the user-facing functions. And what we also tried in the design of the package is to be modular and adaptable. So if we get a new REST API or a HTTP API, that we can also more easily plug that in within the package without a lot of reconfiguring and refactoring the package. So for the implementation, for who's interested, it was actually quite easy to already build upon existing dependencies here. So there was already an interface to the libcurl made by Jeroen Ooms. And then there is also some wrappers that, for instance, help with parsing of JSON. So we have a minimum amount of dependencies, but we do have some dependencies. And further, what is important for the development was the iRODS Docker demo server that makes it easy to stand up a server in a short notice and clean it up and test now over and over again. What we do need to consider, however, is that when we want to push it to CRAN, we don't have internet, we don't have an iRODS server, so we use something like mocking of the responses, recording the responses to ensure that it can still pass. For the maintenance, for now, so everything is on the iRODS GitHub organization. So for the maintainers, the people that you have to approach in the future, that will be me. I'm currently working at the Vienna University of Technology in Austria, and then also Marianne Montes at KU Leuven in Belgium. We also have a website where we list some of the functionality, which you can also find back in the README file. It also has a quite comprehensive reference to all the functions that you can check out. And also important for people that see it now, we also have an article here for if you want to contribute to the development and what you should take care of in that regard. Now for the future, we already submitted it to CRAN. It was already in the hands of a human CRAN member. We do need to revise some part of the package, but we are approaching a stable phase of this project. What I do need to highlight here is that we probably need to wait for an upgrade in the server-side buffer side of the REST API, because the current buffer size is really limiting for the I-put and I-get commands up to now. I have a short demonstration planned. And what I want to point out there is that we use then again the demo server and R 4.1, and I use also a couple of packages to exemplify a workflow in R. And I also use a sort of a case study there, a data set, which is actually the iRODS commit history, and it's under this link. So if you want to follow it, you can find it on the slides and try to reproduce it for yourself. So I will switch now to an R Studio environment. So my favorite EDI for working with R. So we have here our R console, and this is a script. I already set some things here. So if we want to install the package now, we have to do it from source, from GitHub. I won't demonstrate it here, but this is the preferred way to do it. The way to get the package into your global environment would be this call, and then we can fire up the demo server. It was already up and running, so it was quite fast now. And it gives you also the information how you can configure your environment. So just copy paste this one. It's going to be easier. Oh, I have to overwrite this here. I had it already pre-existing. And then we can, with this function, we can connect to the server. Just going to make this a little bit bigger. And then we can also figure out with commands that are quite familiar probably to people where we are within the zone, what we have, for instance. But maybe we also like to create new collections. Let's make something. So if we print this now, we can see that we already have something in RODS here, in home RODS. We can move towards that. And of course, we wouldn't have any data in that. Then we can start a simple workflow here. So I'm not just gonna copy paste parts here. So the packages that I meant, we can get a data set in here. This is what I meant with this commit history. So it gives you the names of the repos of iRODS, whether they are private or not, whether they are archived. So what we could do now is do a very simple workflow here where we filter a part of this. Let's say that we don't want to have forked repos and nothing archived. That would be filtering. Let's store it now. And what we can do now is that we can also use a function that is maybe not so familiar, still prefixed with an ident to identify it. We can store this object directly in iRODS. Oh. And give it a name. And this would be serialized, native serialization for our objects. You see that there will be a little bit of latency there. We can check that it is there. And as I said before, we can also annotate now this data. I'm not going to type this whole part because it's a bit too much, but this would be the metadata that we want to associate with this object. And then attach it to the object. And then we can use else again, but then with the metadata printed, and we see that we can print it as well. So we see that we have now our object in the RDS extension, so this serialization. And we can also bring the object back again directly in memory within our environment. And we get it back. I'm gonna stop the server for now. And that will be it.
All right. Thanks, Martin. Do we have any questions for Martin?
Have there been any considerations of leveraging delayed execution for running these sorts of analysis asynchronously?
At the moment, we haven't, no. So you mean something like promises or?
No, I mean the delayed execution that is built into the iRODS service.
Oh, okay. I thought on our side. No.
Yeah, going the other direction and having iRODS leverage your integration with R.
The other way around, you said?
Yes, yes, being able to run your R scripts asynchronously using iRODS delayed execution.
Yeah, no, we haven't considered it.
That would require the delay server to know how to speak R. Yeah. Okay.
Okay. Any, yeah.
The status for the CRAN.
Mhm.
I think I missed some of that.
So, Martin, there's a question about the status of CRAN.
This is Terrell. Good job. I think I missed maybe with the slide about the CRAN status. I saw an email this morning. What's the?
Yeah, that's maybe my being a little bit unknowing about conventions about whether. So the issue that we have now is the only thing that we write the configuration to the working directory. And we shouldn't do that. We should use the correct location for that. That would be just the config,
Okay.
user config directory. I think it's quite an easy fix.
Yeah. Okay.
So it
That sounds great.
seems to be acceptable in this stage as a CRAN package.
That's great. They worked very hard to make this happen by today. So good job.
I also had a question. I noticed that when you created one file, you didn't specify an absolute path. And so I'm assuming you captured some information about your environment somewhere.
Yeah, I do it in the background. Yeah.
Is that stored locally in RStudio, or is that
Yeah, that is related to your R session. So
okay. Okay. Yeah, I'm not familiar with R, so yeah, that's good to know. Any other questions from anyone?
Is there a lot of interest in this in the room? Martin and I and Mariana have worked on this to make sure that it's good, but we haven't really had any feedback yet. Is this something that is immediately interesting or interesting in 6 months? Or are you hearing demand for this already for people?
The one thing that'd be cool we think about would be adding tooling so that you could annotate the source files to link the analysis you're doing to like the sources, or doing some more things to capture, aspects of the analysis that are done. He did show metadata, but I was wondering if there's a neat opportunity there to do something we do really poorly right now, which is to link analysis to the source data sets and start trying to build up some of that infrastructure. But anyway, it's a really impressive demo though. Good work.
Yeah, I think the workflows and the seamlessness will come as soon as 3 other nerds play with it some more, right?
So answering to what you asked, I've seen 2 flavors of this. One is people who want to have reproducibility, and they're doing this more from a compliance point of view. Yeah, and so fetching the data and having a URI that still has some level of authentication, or making sure that it's not like an open URI. That's one class. The other class of applications, which I think I see more often and maybe out of scope for this, but is a common thing in bioinformatics, is a lot of our biostatisticians will use exec and shell out to a program to do something, but that data is not, it's still coming from a repository. And so I'm not sure how to balance that out, where if they're trying to read a FASTQ file that's 10 gigs, you're not trying to now make that reproducible through this API. So you might have to manage expectations of people as you show this to our users, that this is what you can do and this is the sweet spot. Don't try and get your 10 gig file through this, yeah, so that's the caveat, or something that the awareness should be there. But all the other sort of typical functions of pulling summarized files, visualizing them, saving things back, and keeping track of that, this is really awesome for that.
Yeah, you make it too easy and then people want to use it. It's the worst. Anybody else?
All right. Well, thank you, Martin.